Hi everyone, and so we're going to continue with the center limit theorem for means. And so the second part we're going to talk about is finding the probability. And so let's recap what we learned from the first video. The center limit theorem tells us that the mean for x bar is going to be the population mean mu. The standard deviation for x bar is the population standard deviation divided by the square root of our sample size. And the shape is going to be approximately normal if we have a random sample and the sample size is large enough. And so to find the probability, you find a z-score like we did earlier. The only difference is our standard deviation there at the bottom. And so what you have to do is find the z-score. And so you take the sample mean x bar minus your population mean mu and divide it by your standard deviation for x bar. And so you find your z-score first, and then what you're going to do is you're going to need your calculator to help you find the probability. And so go ahead and pause the video and get your calculator out. That way you can use them for the next couple of problems that we're going to look at. And so let's take a couple of examples. Let's say we have scores on the ACT exam. They have a normal distribution with a mean of 20.6 and a standard deviation of 4.8. Let's say at Mayfield High School, 36 seniors take the test. And so we want to know what is the probability that their average score is going to be more than 22.5. And so we're going to take this like we did with z-scores earlier. You can draw this out if you want. You don't have to. But here we still have the normal distribution. The mean for the ACT is 20.6. And we want to know from those 36 seniors, is their average score for the ACT going to be greater than 22.5? And so what we want to do is find the z-score. And so we have z equals our sample mean minus the population mean divided by the standard deviation for x bar. And so when we set this up, we're going to have our sample mean, the 22.5, minus the mean for the ACT, 20.6, divided by 4.8, and that's divided by the square root of our sample size, 36. And so why don't you find that value there? And so if you found that value, and I'm going to just put it up here, I'm running out of room, you should have got 2.34. And so if we think about this, the mean, the average mean for these 36 seniors, they are 2.34 standard deviations above the population mean. And so we need the z-score to help us find the probability. And so what we can do is we're going to take our calculator out. And so before we look at the calculator, I do want to make a note. We're going to use a different function than what we have looked at. Actually, we have looked at this, let me recall. We did this when we looked at regular z-scores, the normal CDF. And so remember, there are 4 things we're looking at for this normal CDF. And so when we look at this, we're going to want our lower bound. We're going to need our upper bound. Here goes the mean. Here goes the standard deviation. And here we're going to be talking about x bar. So I'm going to put x bar there for us. And so it's going to be like what we did when we looked at regular z-scores. And so why don't you get your calculator out? as I go to mine. And so what we have here is, remember, you want to go to second. It does help if you turn it on. You want to go second VARS. You want to go down to normal CDF. Here, our lower bound is going to be the 22.5. We're looking to see if the probability is greater. And so that's going to make the 22.5 our lower bound. And so we're going to go to infinity. And so you can hit second, the comma button to bring out E for 99, comma, the mean 20.6, comma, and then when you type in the standard deviation, if you found the actual number, you can put it in, or you can put it in like this. Just make sure you put it inside parentheses. And so here we would get the probability 0.00877. And so the probability that these seniors, that their average mean for the ACT is more than 22.5, is about 0.88%. And so not even 1% right here. And so that's how we can use the calculator to find the probability for the z-score for the center limit theorem. And so we're going to take another example. And so let's say we have some snake specialists, and they found that a certain species of these pythons have an average length of 20.5 feet with a standard deviation of 2.3 feet. The scientists collect a random sample of 30 pythons and measure their lengths. We want to know what is the probability that their average length is actually going to be smaller than 19.5 feet long. And so again, let's just find the z-score. It never hurts to find the z-score and understand what it's telling us. And so, again, you can make yourself a sketch. Here's the normal distribution. Here, the mean for these pythons is 20.5. And so our sample mean came out to be 19.5. And we want to see, is their average mean going to be, what's the probability that their average mean is smaller than 19.5. And so again, you can find that z-score if you would like. And so z equals, here our sample mean of 19.5 minus 20.5 divided by the standard deviation for x bar. And so why don't you find that value there? And so if you found that value, you should get, I believe, minus 2.38. And so here for these 30 pythons, their average length is 2.38 standard deviations below the mean. And so again, we can go to our calculator to find the probability. And so why don't you take your calculator out? So let's clear this. You're going to hit second VARS, go to your normal CDF, click enter. And so here we want to see if it's actually lower than 19.5. And so you're going to hit minus second comma for the minus infinity, then comma, the 19.5, comma, then you're going to hit the mean for the python's length, and then you're going to hit the standard deviation as well. And so you click enter, and here we get 0.0086. And so the probability that these 30 pythons, that their average length is smaller than 19.5 is about 0.86%. And so not even 1% here. And I didn't put these two problems close like this on purpose. It's just by accident they have come up like this here. And so this is how you can find the probability for the center limit theorem when we look at just one on one side, either greater or less than. Let's take another example and let's look at what happens when we have to look at in between. And so we can do exactly the same thing that we learned from z-scores. And so let's say the time it takes students in a cooking school to learn to prepare seafood gumbo has a normal distribution with the average time of 3.2 hours and has a standard deviation of 1.8. We want to find the probability that it takes 36 students between 3.1 and 3.5 hours to learn to prepare seafood gumbo. And so let's not worry about finding the z-score. Let's just go straight to the calculator and find the probability. And so write this down that our population mean is the 3.2. The standard deviation is 1.8. We're looking at 36 for our sample size. And we want to know the probability for in between of 3.1 and 3.5. And so pause the video and write those values down. And so hopefully you have those written down. And so let's go back to our calculator. Let's clear that. And so again, go to second VARS. You're going to hit normal CDF. And so now we're looking at in between. And so here we have, what was our numbers again? Ah, yes. 3.1 and 3.5. Sorry, I guess I should have written those down as well. And so 3.1 is our lower bound. 3.5 is our upper bound. We had a mean of 3.2. And here our standard deviation is going to be the 1.8 divided by the square root of 36. And so here we have a probability of about 47.2% that the time taken is going to be between 3.1 and 3.5 hours. And so this isn't a whole different from finding z-scores when we had just one sample. But you do want to make sure you remember we're looking at more than one person. We're looking at multiple. And so you want to make sure you add that in when we talk about the center limit theorem. And so that's how you find the probability with your calculator using the center limit theorem.